In September 1944, an American Sikorsky R-4 helicopter made an emergency landing in German-occupied Holland after suffering mechanical failure during a medical evacuation mission behind enemy lines. Within days, the world's first production helicopter, an ungainly contraption of fabric, steel tubing, and a piston engine that could barely exceed 75 miles per hour, was transported to the Luftwaffe's testing facility at Ainring, where German pilots and engineers would experience a moment of profound cognitive dissonance. Germany had pioneered helicopter development, had flown helicopters before America, had designed helicopters more sophisticated than this primitive American machine. Yet here was an enemy helicopter that represented something Germany could no longer achieve. Not technical brilliance, but mass production, operational reliability, and systematic deployment of a new technology while fighting a global war. What German test pilots discovered would force them to confront an uncomfortable truth about why Germany was losing, not because German engineers lacked skill, but because American industry had transformed experimental technology into routine operational capability, while Germany's advanced prototypes remained scarce, fragile, and operationally irrelevant. This is the story of how a simple helicopter revealed the gap between technical achievement and industrial victory. Subscribe now for the untold engineering stories of World War II, where the battles weren't always about who had the best technology, but who could build it, deploy it, and sustain it in combat. We're bringing you research no other channel covers. Hit subscribe. September 23, 1944. Ainring Airfield, Bavaria, Germany. The autumn morning is cool, mist hanging over the airfield near the Austrian border, the Alps visible in the distance as dark blue shadows against a pale sky. Hauptmann Anton Flettner stands on the grass beside the runway, arms crossed, studying the aircraft, if it can be called an aircraft, that sits incongruously on German soil. The Sikorsky R-4B helicopter, serial number 4346506, looks like something assembled in an inventor's workshop rather than a military production facility. The fuselage is a fabric-covered steel tube frame, the tail boom a simple welded assembly, the rotor blades wooden with fabric covering. The entire contraption appears fragile, temporary, almost toy-like, yet this toy has traveled 4,000 miles from America to Europe, has flown operational missions, has saved lives, and represents something that makes Flettner deeply uneasy. American mass production of rotary wing aircraft, while Germany's helicopter program, despite technical superiority, remains locked in experimental development. Flettner's 38 years old, one of Germany's pioneering helicopter designers, the engineer behind the FL-282 Colibri helicopter. He is not primarily a test pilot, he is an inventor, a designer, a man who has devoted 15 years to solving the problems of rotary wing flight. He has flown every German helicopter, the Focke-Wulf FW-61 that first flew in 1936, the Focke-Tullis Fa-223 Drake transport helicopter, and his own FL-282 Colibri reconnaissance helicopter. He understands helicopters at a level few Germans and fewer Americans can match, and that understanding makes this moment particularly bitter. The American helicopter before him is primitive by German standards. The control system is crude. The rotor hub is unsophisticated. The engine is underpowered. Yet America has built over 100 of them. Germany, with superior designs, has built perhaps 30 helicopters total across all types. The numbers tell a story Flettner does not want to hear but cannot ignore. The R-4 was captured 8 days ago near Arnhem during the chaos of Operation Market Garden. An American medical evacuation helicopter operating behind German lines to retrieve wounded paratroopers experienced engine failure and auto-rotated into a field controlled by German forces. The pilot, First Lieutenant Carter Harmon, 26 years old, from New York, and his medical passenger were captured before they could destroy the helicopter. German troops, recognizing the helicopter as valuable intelligence, transported it initially by truck to a Wehrmacht depot, then by rail to Ainring, where the Luftwaffe maintains a helicopter testing facility, specifically because of Flettner's work there. The R-4 arrived 5 days ago. Luftwaffe mechanics have spent those 5 days studying it, documenting it, repairing it, making it airworthy again. The repairs were surprisingly easy. The helicopter is simple. Almost everything is accessible. Parts are standardized. The American designers prioritized ease of maintenance over sophistication. German helicopters prioritize performance over maintainability. The American approach, Flettner recognizes reluctantly, is more practical for military operations. Behind Flettner, 3 other men wait in the cool morning air. Hauptmann Hanna Reich, 32 years old, Germany's most famous female pilot and one of the world's first female helicopter pilots. Holder of the Iron Cross First Class for test flying dangerous experimental aircraft, including helicopters. Oberfeldwebel Kurt Schwenke, 29 years old, a helicopter mechanic and pilot who has maintained and flown every German helicopter type, and Lieutenant Heinrich Schinn, 24 years old, an engineer from Bocachalis assigned to evaluate enemy rotorcraft technology. Each has specific responsibilities. Flettner will fly first, conducting initial evaluation from a designer's perspective. Reich will fly second, evaluating operational handling and combat suitability. Schwenke will conduct maintenance assessment, determining how the R4's simplicity affects field operations. Chen will document technical details for intelligence reporting. Together they will answer a question that makes German helicopter pioneers uncomfortable. How did America, which did not have a functioning helicopter until 1942, produce over 100 operational helicopters by 1944, while Germany, which flew helicopters in 1936, has fewer than 30? Before approaching the helicopter, Flettner interviews the captured American pilot, Lieutenant Harmon, who is being held at a nearby POW facility. The interview occurs in a spare room at the base commander's office, Harmon sitting on one side of a wooden table, Flettner on the other. A translator present, though Flettner speaks adequate English. Harmon is cooperative. Helicopter pilots are not frontline combatants, and discussing technical details of an aircraft the enemy has already captured does not violate security protocols. Flettner asks about training. Harmon explains that he learned to fly helicopters in 4 months at the Sikorsky factory in Connecticut, starting with no helicopter experience, progressing through ground school, basic flying, advanced maneuvers, and operational procedures. Total training time, approximately 60 hours of helicopter flight time. Flettner is surprised. German helicopter pilots require 6 months minimum training, often longer. The American training is faster, more standardized, more efficient. Flettner asks about operations. Harmon describes flying medical evacuation missions in Burma for 6 months before being transferred to Europe. He flew casualty evacuations from jungle locations where fixed-wing aircraft could not land, typically flying 2 to 4 missions per day, transporting wounded soldiers from forward positions to field hospitals. The R4 could carry 1 litter patient plus the pilot, or 2 seated passengers plus pilot. Range was approximately 130 miles. Typical missions lasted 45 minutes to 1 hour. The helicopter required maintenance after every 10 flight hours, routine maintenance, oil changes, inspections, nothing major. Major maintenance occurred every 50 hours. Engine overhaul at 150 hours. The maintenance requirements were designed to be performable by standard Army mechanics with basic training. Nothing required factory specialists. Harmon says the R4 was reliable, simple to operate, easy to maintain. Its limitations were speed maximum 75 miles per hour and payload approximately 400 pounds beyond the pilot. But within those limitations, it was effective. It saved lives. It operated in weather and terrain where fixed-wing aircraft could not. It proved the concept of helicopter operations. Flettner asks about production. Harmon explains that Sikorsky built R4s at a rate of approximately 10 per month through 1944, delivered to Army Air Forces, Navy, and Coast Guard. Training programs produced new helicopter pilots at a rate of 15 to 20 per month. The entire system production, training, operations, maintenance was designed as an integrated program, not as experimental development. The R4 was not the best helicopter possible, Harmon admits. It was the best helicopter that could be built in quantity, maintained by regular mechanics, and flown by trained pilots in operational conditions. That distinction, Flettner realizes, is everything. The interview ends. Flettner thanks Harmon for his cooperation. Harmon asks if Flettner designs helicopters. Flettner says yes, he does. Harmon says, then you understand how difficult this is, making these machines reliable enough for regular troops to use. Mr. Sikorsky solved a lot of problems to make the R4 work in the field. I hope you can learn from it. Flettner says nothing, nods, leaves. The American pilot's words stay with him. The R4 has been made airworthy by Luftwaffe mechanics working under Schwentz's supervision. The damage from the forced landing was minimal. Bent tail rotor blade, damaged landing gear strut, minor structural damage to the tail boom. The mechanics fabricated a replacement tail rotor blade using measurements from the damaged one. The landing gear was straightened. The tail boom was reinforced. The Warner R5503 Super Scarab engine, a 7-cylinder radial producing 185 horsepower, required only minor adjustment and fresh oil. The engine is simple, reliable, based on proven aircraft engine technology. German helicopter engines, the Siemens Halske SH-14 and the FL-282, the BMW Brahmo 323 and the FA-223 are more powerful but also more complex and temperamental. The R4's engine is underpowered but dependable. The rotor system required careful inspection. The main rotor is 38 feet in diameter, 3 blades, wooden construction with fabric covering. The rotor hub uses a design Flettner finds primitive individual blade pitch control through mechanical linkages. No sophistication, just direct mechanical connection. German helicopters use more advanced control systems with better responsiveness, but the American system is simple, easy to repair, difficult to break. The trade-off is obvious: performance versus reliability. Flettner walks around the R4 examining every detail with the designer's eye. The fuselage is approximately 35 feet long, 9 feet high, a simple tubular steel frame covered with fabric. The construction is more like a light aircraft from the 1920s than a modern warplane. The cockpit is open-sided with a plexiglass windscreen and removable fabric panels for cold weather. 2 seats side by side, simple instruments, basic controls. The cyclic control stick between the pilot's legs controls forward, back, left, right movement. The collective control lever on the left side controls vertical movement. Pedals control tail rotor and yaw. Simple, intuitive, easy to understand. The tail boom extends rearward, a simple welded tube structure supporting the tail rotor. The tail rotor is small, 2 blades, providing anti-torque control. The landing gear is fixed, no retraction mechanism, simple oleo struts with wheels. Everything about the R4 is straightforward, accessible, designed for ease of construction and maintenance. Nothing is hidden, nothing is complex. This is engineering for mass production, not for optimal performance. Flettner climbs into the left seat, the pilot's seat in the R4. Unlike German helicopters where pilots typically sit on the right, the seat is lightly padded, adequate but not comfortable. The instrument panel is sparse: airspeed indicator, altimeter, engine RPM, manifold pressure, oil temperature. No artificial horizon, no turn coordinator, minimal instruments. Helicopter flying is visual, and the American designers assume pilots will fly by looking outside, not at instruments. The cyclic stick is directly in front of him, sprouting from the floor between his legs. The collective lever is on his left, connected to the rotor pitch mechanism through cables and pulleys. The pedals are straightforward, connected to the tail rotor. A German mechanic, Unteroffizier Franz Weber, climbs up beside the cockpit to provide briefing. Weber has studied the R4's manual, captured with the helicopter, translated sections relevant to operation. He explains the startup procedure: fuel on, throttle to idle, magneto switch on, engage starter. The engine is electric start, requiring external battery cart or hand cranking. Weber warns that the engine must warm for at least 2 minutes before attempting flight. The Warner radial is air-cooled and requires adequate temperature for oil circulation. He warns that rotor RPM must be maintained between 230 to 250 RPM for flight, too low, and the helicopter cannot maintain altitude. Too high and structural stress may damage the blades. He warns that the R4 is underpowered and cannot hover at full gross weight above 5,000 feet density altitude. At Einring's elevation of 1,400 feet, this should not be a problem, but it limits operational capability in mountains or hot weather. Flettner settles into the seat, positions his hands on the controls, familiarizes himself with their location and feel. The cyclic stick moves freely, moderate resistance, requiring smooth inputs. The collective lever is heavier, requiring force to raise or lower. No hydraulic assist, pure mechanical advantage through gearing. The pedals are light, responsive. Everything feels direct, mechanical, unassisted. German helicopters are similar, but German designs tend toward lighter controls and faster response. The R4 feels sluggish by comparison, but perhaps that sluggishness provides stability. He signals Weber he is ready. Weber climbs down. An external battery cart is connected. Flettner follows the startup procedure. Fuel selector on, throttle to idle position, magneto switch on. He presses the starter button. The Warner R550 cranks, coughs once, catches with a rattling roar characteristic of radial engines. The engine settles into a rough idle at 800 RPM, vibrating noticeably. The wooden rotor blades, still engaged through a clutch mechanism, begin rotating slowly. Flettner monitors the engine instrument, soil pressure climbing to 40 psi, oil temperature rising slowly, all normal. He allows the engine to warm for 3 minutes, watching temperature stabilize. When oil temperature reaches operating range, he engages the rotor clutch fully. The main rotor accelerates from idle to operating RPM, the blades accelerating with a rising whoosh of air. The helicopter vibrates as the rotors reach speed, then smooths out as balance is achieved. The rotor RPM stabilizes at 240 RPM within normal range. Flettner tests the controls individually. He moves the cyclic stick forward, the rotor disc tilts forward. Back, the disc tilts back. Left, the disc tilts left. Right, the disc tilts right. The response is smooth, linear, predictable. He raises the collective. The rotor blades increase pitch, generating more lift. The helicopter lightens on its landing gear. He lowers the collective. The blades decrease pitch. The helicopter settles. He tests the pedals. Left pedal decreases tail rotor pitch, yaw to the right. Right pedal increases tail rotor pitch, yaw to the left. Everything functions correctly. The controls are heavier than German helicopters, but not excessively so. The American design uses mechanical advantage rather than power assist. Simple, reliable, adequate. He is ready for flight. He increases engine power slightly, raises the collective smoothly. The rotor blades bite the air with increasing authority, the lift building, and at approximately 3/4 collective, the R4 becomes light on its wheels, then lifts gently into the air. Flettner maintains the hover at 5 feet, concentrating on control inputs. The R4 is stable in hover, requiring constant but not excessive control inputs to maintain position. The cyclic response is slower than German helicopters. Inputs take longer to produce results, but the sluggish response provides stability, making it easier for less experienced pilots to fly smoothly. German helicopters are more responsive, more agile, but also less forgiving of pilot errors. The R4 forgives errors through its inherent stability. Flettner hovers for 2 minutes, making small movements left, right, forward, back. The helicopter responds predictably. He applies forward cyclic, and the R4 begins moving forward, accelerating to 10 knots, 20 knots, 30 knots. He raises the collective to maintain altitude, increases power. The Warner engine responds adequately, not powerfully but sufficient. At 40 knots airspeed, the R4 is flying efficiently. The rotor disc providing good lift, the tail rotor keeping the fuselage aligned. Flettner climbs to 500 feet, levels off, accelerates to maximum speed. The airspeed stabilizes at 70 knots, approximately 80 miles per hour. The R4's maximum speed is 75 miles per hour. He is achieving near maximum performance. By comparison, the FL-282 Colibri achieves approximately 93 miles per hour maximum speed. The FA-223 Drakey achieves approximately 109 miles per hour. German helicopters are faster, but they are also heavier, more complex, more difficult to maintain, and produced in tiny numbers. The R4 is slower, but exists in quantity. Flettner flies for 30 minutes, testing the R4's handling at various speeds and altitudes. He performs turns, climbs, descents, approaches to hover. Everything is smooth, predictable, stable. The R4 is not exciting to fly. It is not agile. It does not have impressive performance. But it is easy to fly, forgiving of errors, reliable in operation. A pilot with 60 hours of training could operate this helicopter safely. German helicopters require double that training time and still experience higher accident rates due to their demanding handling characteristics. Flettner performs an autorotation, simulating engine failure, a critical maneuver for helicopter safety. He reduces engine power to idle, lowers the collective immediately to maintain rotor RPM, establishes a descent at 60 knots. The R4 descends at approximately 1,200 feet per minute, the rotor maintaining RPM through the airflow from the descent. At 100 feet, he flares, raising the nose to reduce forward speed and descent rate, cushioning the landing with stored rotor energy. The R4 touches down gently. The autorotation is stable, controllable, survivable. German helicopters have more demanding autorotation characteristics, requiring precise pilot technique. The R4's stability makes engine failure landings routine rather than emergency. After 45 minutes of flight, Flettner returns to Ainring, approaches to hover, descends gently, and lands. He reduces power to idle, disengages the rotor, shuts down the engine. The Warner radial coughs, backfires once, falls silent. Flettner sits in the cockpit for several minutes, processing what he just experienced. The R4 is not a better helicopter than German designs in terms of performance. It is slower, has less payload capacity, has lower service ceiling, but it is a better helicopter in terms of operational suitability. It is simple enough to mass produce. It is reliable enough to operate routinely. It is easy enough to fly that adequate pilots can be trained quickly. And most importantly, it exists in numbers that make it operationally relevant. Germany's superior helicopter designs are irrelevant if only 30 exist, and if operational deployment is so limited that most German soldiers have never seen a helicopter. America's inferior helicopter design is significant because 100 plus exist and are deployed globally, saving lives, proving concepts, establishing rotary wing aviation as a practical military capability. Flettner climbs down from the cockpit, his expression somber. Hannah Reich is waiting. She asks what Flettner found. Flettner looks at her and says, "I found a helicopter that works. Not a brilliant helicopter, not an advanced helicopter. A helicopter that works reliably for regular operations. We have built brilliant prototypes. America has built working tools. There's a difference, Hannah, a very large difference." Reich nods. She understands. She has flown the FA-223, has experienced its tremendous power and its mechanical unreliability. She has flown the FL-282, has experienced its agility and its demanding handling. She knows German helicopters are advanced but fragile. She climbs into the R-4 for her flight. Reich's flight profile is operational, simulating the missions American pilots fly. She takes off, climbs to 1,000 feet, flies cross-country at maximum cruise speed to a designated landing zone 10 kilometers away. She lands in a small clearing, hovers precisely, touches down in an area barely larger than the helicopter's footprint. She waits 30 seconds, simulating loading a wounded soldier, takes off again, flies back to Ainring. Total mission time, 28 minutes. She repeats the mission 3 times, varying the approach angles and landing areas, simulating different tactical situations. The R-4 performs adequately each time. She discovers that the helicopter's stability makes precision landings easier than in German helicopters. She discovers that the sluggish controls, which seemed like a disadvantage initially, actually help in confined areas where overcorrection is dangerous. She discovers that the low power margins require careful planning. She cannot hover at full gross weight in hot conditions or at altitude. But within known limitations, the helicopter performs reliably. She lands after the 3rd mission, her assessment clear. This helicopter is not impressive to fly, but it is practical to operate. It does what it needs to do, and it does it repeatedly without breaking. That is more valuable than impressive performance that cannot be sustained. Schwenke conducts maintenance assessment, a critical evaluation that reveals why the R-4 succeeds operationally where German helicopters struggle. He examines the Warner R550 engine with a mechanic's eye, noting that every component is accessible without removing major assemblies. Oil changes require 20 minutes. Spark plug inspection requires 15 minutes. Nothing is hidden behind complex structure. The rotor head, the most complex component of any helicopter, is surprisingly simple on the R-4. The pitch control mechanism uses straightforward mechanical linkages, push rods, bell cranks, bearings all visible, all replaceable with basic tools. German helicopters use more sophisticated control systems with better response, but requiring specialized tools and factory-trained mechanics for maintenance. Schwenke estimates that a mechanic with basic training could maintain the R-4, with 2 weeks of specialized instruction. Maintaining an FL-282 requires 6 months of training. The difference determines whether helicopters can deploy to field units with regular support personnel or whether they remain tied to specialized facilities with expert technicians. The Americans chose the former. The Germans achieved the latter by necessity of complexity. Schwenke discovers that the R-4's fabric covering, which seems primitive compared to the metal skin on German helicopters, is actually advantageous for field repairs. Fabric can be patched with basic materials, dope, cloth, sewing by mechanics with minimal specialized training. Metal skin requires specialized tools, welding equipment, metalworking skills. He examines the landing gear, discovering it is designed to absorb heavy landings without permanent damage. The oleo struts have generous travel. The mounting points have built-in flexibility. German helicopters, optimized for weight savings, use stiffer landing gear that transmits impact loads to the airframe, causing cumulative structural damage. The American approach accepts slightly heavier landing gear to prevent airframe damage, extending service life. Schwenke's report concludes, the R-4 represents American design philosophy of maintainability, reliability, and longevity over optimal performance. Every design choice prioritizes operational sustainability. The result is a helicopter that can operate continuously with minimal downtime. German helicopters require extensive maintenance, specialized support, and frequent repair. The R-4's approach is operationally superior for military deployment. Heinrich Gunn conducts technical documentation, photographing every component, measuring every dimension, documenting every mechanism. His analysis focuses on manufacturing methods. He discovers that the R-4 uses standardized components wherever possible, standard bolts, standard bearings, standard fasteners, allowing parts to be sourced from general inventory rather than custom manufactured. German helicopters use custom components throughout, requiring specialized manufacturing and creating supply chain bottlenecks. He discovers that the R-4's construction uses simple techniques, welding, bolting, fabric covering, that can be performed by semi-skilled workers with basic training. German helicopters require skilled craftsmen, precision machining, complex assembly procedures. The American approach enables rapid production scaling. The German approach limits production to facilities with specialized capabilities. Chin calculates that a factory producing R-4 South could train workers and begin production within 6 months. A factory producing FL-282s would require 18 months to establish specialized capabilities. Time to production matters when fighting a war. America had time, Germany did not. September 25, 1944. The 4 evaluators compiled their findings into a comprehensive report. Flettner writes the technical assessment comparing the R4's capabilities against German helicopters. The data is sobering. Speed: R4, 75 miles per hour maximum FL 282 Calibri, 93 miles per hour maximum FA 223, Drake, 109. MPH maximum German advantage, 18 to 34 miles per hour. Payload beyond pilot, R4, 400 pounds, FL 282, 350 pounds, FA 223, 1,800 pounds. Mixed results. R4 exceeds FL 282, far below FAT 223 range. R4, 130 miles FL 282, 106 miles FAT 223, 186 miles. Mixed results. R4 exceeds FL 282, below FAT 223 production. R4, 131 built by September 1944, FL 282, 24 built total FAT 223, 11 built total American advantage, 4 to 12 times. Greater production. The numbers tell two stories. In performance metrics, German helicopters are competitive or superior. In production metrics, American helicopters are overwhelmingly dominant. Flettner's analysis states, German helicopter designs achieved superior performance through advanced engineering. The FI 223 Drake is the world's most capable transport helicopter. The FL 282 Calibri is an excellent reconnaissance platform. But superior design is operationally irrelevant if production numbers are insufficient for deployment. America has produced 131 R4 helicopters. Germany has produced 35 helicopters total across all types. American helicopters are operational in Burma, Europe, and the Pacific. German helicopters remain experimental, deployed only in limited trials. The R4 proves that adequate performance delivered in quantity is strategically superior to excellent performance delivered in inadequate numbers. Reich contributes an operational pilot's perspective, describing the practical differences between flying German helicopters and the R4. She writes, "The R4 is stable, forgiving, predictable. Pilots with moderate skill can operate it safely. German helicopters are responsive, agile, demanding. They require exceptional pilots for safe operations. The American approach enables rapid training and deployment of adequate pilots. The German approach requires extensive training and limits deployment to elite pilots. Given the reality of wartime pilot availability, the American approach is correct. We cannot sustain a helicopter force requiring elite pilots when elite pilots are needed for fighter and bomber operations. The R4's design allows helicopter operations by regular pilots, making rotary wing aviation practical for military use." Schwenke contributes maintenance analysis, documenting the dramatic differences in field supportability. His report includes time estimates for common maintenance tasks: oil change, RYY minutes, FLPC, Y minutes, FAP, Y minutes. Engine inspection, R for 45 minutes, FL 282 to 90 minutes, FA 223 to 120 minutes. Rotor blade replacement, R4, 2 hours 2 mechanics, FL 282, 4 hours 3 mechanics. Specialized training FA 223, 6 hours 4 mechanics. Specialized training major repair battle damage, R4. Possible at field level with basic tools, FL 282, requires factory support. FA 223, requires factory support. Schwent's conclusion states, the R4's maintainability enables operational deployment to field units with standard support personnel. Chin contributes manufacturing analysis, examining why America achieved mass production while Germany did not. His findings identify 3 critical factors. Design philosophy. The R4 was designed from the beginning for mass production. Components are simple, standardized, easily manufactured. German helicopters were designed for performance, with manufacturing difficulty considered secondary. Redesigning for production would require starting over, losing years of development. The R4 can deploy anywhere Army units operate. This difference determines whether helicopters are experimental curiosities or operational tools. Industrial capacity. American aircraft factories had excess capacity that could be allocated to helicopter production without impacting fighter or bomber output. German aircraft factories were operating at maximum capacity, with no ability to add new production lines without reducing output of critical combat aircraft. Adding helicopter production meant reducing fighter production, an unacceptable trade-off. Supply chain. The R4 uses standard aviation components available from general suppliers. German helicopters use custom components requiring specialized suppliers. American supply chains could support helicopter production through existing networks. German supply chains, already strained, could not support additional specialized requirements. Chin concludes, Germany could design helicopters superior to the R-4. Germany cannot produce helicopters in quantities approaching American output. The limitation is not engineering capability but industrial capacity and strategic priorities. Helicopter production requires resources allocated elsewhere. America has resource abundance allowing simultaneous programs. Germany must choose priorities, and helicopters rank below fighters, bombers, and ground attack aircraft. The final section, Recommendations, is written by Flettner with heavy heart. He knows his recommendations will not be implemented, cannot be implemented, given Germany's situation in September 1944, but professional integrity requires honest assessment regardless of political palatability. He recommends immediate simplification of German helicopter designs for production, redesign the FL-282 eliminating complex components, accepting performance penalties to enable mass production, development time, 12 months, production start, late 1945 at earliest, too late to affect the war, reallocation of production capacity to helicopters, reduce fighter production by 5% to enable helicopter production of 20 units per month. Militarily unacceptable fighter production is already insufficient for defensive needs. Development of standardized helicopter training program. Create training curriculum enabling pilot qualification in 60 days rather than 180 days. Requires experienced instructor pilots, specialized training aircraft, dedicated facilities, resources unavailable. Establishment of field maintenance support structure. Train mechanics in helicopter maintenance. Create spare parts distribution network. Develop field repair procedures. Requires diversion of mechanics from other critical duties. Not feasible. Strategic acceptance that German helicopter development will not influence the war's outcome. Focus helicopter research on post-war applications rather than attempting impossible wartime deployment. Most realistic recommendation, most politically unacceptable. Flettner writes in the conclusion, the R-4 evaluation reveals that American success in helicopter development stems not from superior engineering, but from superior industrial strategy. America identified helicopter technology as operationally useful, allocated resources for production, created support infrastructure, and deployed helicopters systematically. Germany identified helicopter technology as interesting, developed advanced prototypes, produced insufficient numbers for operational impact, and treated helicopters as experimental rather than operational. Both approaches were logical given each nation's circumstances. America, with resource abundance, could invest in emerging technologies with uncertain military value. Germany, with resource scarcity, could not justify production of capabilities not immediately critical. The result is that America operationally deploys technology Germany invented. This pattern German invention, American production characterizes multiple technologies. Jets, rockets, helicopters. Germany leads in innovation. America leads in application. The war is won by application, not innovation. The report is dated September 26, 1944. Classified Geheim, secret, and forwarded through channels to the Reichsluftfahrtdienst. It is 52 pages, typed, with 37 photographs and 12 technical drawings. Flettner personally delivers it to Berlin on September 28. The report is received by Oberst Siegfried Niemeyer, Chief of Technical Development, who reads it over 2 days. Niemeyer is a realist, an engineer, a man who understands industrial limitations. He calls Flettner to his office on September 30th. The office is in the Reich Aviation Ministry building on Leipziger Strasse. A massive stone structure showing scars from bombing, repaired windows, patched walls, the smell of plaster dust still present. Niemeyer's office is 4th floor, papers stacked on every surface, technical drawings covering the walls. Niemeyer gestures for Flettner to sit. He says, "Your report is accurate. Your recommendations are impossible. We cannot produce helicopters in meaningful numbers. We lack capacity, resources, time. The war will end before we could establish production. But I want you to understand something. Your work, the work of German helicopter pioneers, is not wasted. You have proven rotary wing flight is practical. The Americans took your proof of concept and industrialized it. After the war, whoever wins, helicopters will be important. Your engineering will be the foundation." That is worth something. Flettner says it is worth little if Germany loses and our technology benefits others. Niemeyer responds, "Technology has no nationality. Physics works the same everywhere. You solved aerodynamic problems that needed solving. Sikorsky built production helicopters based on solutions you and Foch pioneered. That is how progress works. One man discovers, another man applies. Both contribute. You should feel pride, not bitterness." Flettner says nothing. Pride is not what he feels. The report is forwarded to Hermann Gring with a cover memo from Niemeyer stating that the R-4 evaluation confirms American industrial superiority in emerging technologies, that Germany cannot compete in helicopter production, and that resources should focus on technologies with immediate combat impact jets, rockets, improved conventional aircraft. Gring's response is brief, dismissive. Helicopters are experimental toys with no combat value. The American helicopter proves nothing except American tendency to waste resources on impractical equipment. No further helicopter development is justified. Existing programs will continue at current levels but no expansion. The report is filed. No action is taken. Helicopter production continues at experimental levels, 1 or 2 FL-282s per month. FA-223 production ended due to bombing of the factory. By war's end, Germany will have produced fewer than 50 helicopters total. America will have produced over 400, but Gring is wrong about helicopters having no combat value, and the R-4's operational record proves it. By September 1944, R-4 helicopters have flown hundreds of medical evacuation missions in Burma, rescuing wounded soldiers from locations where fixed-wing aircraft cannot land. They have conducted liaison missions in Europe, transporting commanders to forward positions unreachable by road. They have performed search and rescue missions in the Pacific, recovering downed pilots from jungle and water. They have proved that helicopters can operate routinely in combat zones, that they provide unique capabilities no other aircraft offers, that they are not experimental toys but operational tools. German leadership's dismissal of helicopter value reflects broader failure to recognize how warfare is evolving, how mobility and flexibility matter, how specialized capabilities can provide strategic advantages despite limited tactical impact. The captured R-4 continues flying at Ainring through October and November 1944, with additional pilots given familiarization flights. Younger pilots, those with open minds not calcified by pre-war assumptions, recognize the R-4's significance immediately. One pilot, Lieutenant Klaus Becker, 23 years old, writes in his personal diary after flying the R-4, "This machine is not impressive by any performance measure. It is slow, weak, limited. But it does something no airplane can do. It lands in a space barely larger than itself, hovers precisely, takes off vertically. Imagine using these for mountain rescue, medical evacuation, reconnaissance in cities or forests, supply delivery to isolated positions. The applications are endless. We Germans invented this capability. The Americans are using it. After the war, helicopters will be everywhere. We will remember that we flew them first, but did nothing with them." In December 1944, the R-4 is damaged during a test flight when a sudden wind gust during landing causes a hard touchdown that collapses the landing gear and damages the tail boom. The helicopter is repairable, but parts are unavailable. Germany has no spare parts for American helicopters. The R-4 is retired from flight testing, disassembled for detailed study. The engine is sent to BMW for examination. The rotor blades are sent to various research facilities for structural analysis. The control system is documented thoroughly for post-war reference. The fuselage remains at Ainring, used for maintenance training, teaching mechanics how to work on helicopters using the R-4's simple systems as examples. In April 1945, as Allied forces advance into Bavaria, Ainring is evacuated. The R-4 fuselage is intentionally destroyed to prevent capture. Some components are saved, hidden, preserved for post-war recovery. Most are lost. Post-war, the helicopter pioneers scatter. Flettner is captured by Allied forces. Interviewed extensively by American and British intelligence, his knowledge of helicopter technology considered valuable. He is eventually released, emigrates to the United States in 1947. Works for the Office of Naval Research and later for Coleman Aircraft, continuing helicopter development in America. He is interviewed in 1962 by an aviation historian researching wartime helicopter development. Flettner describes the R-4 evaluation. Flying the R-4 was humbling. Not because the aircraft was impressive, it was not, but because it existed in numbers that made it significant. We Germans built better helicopters that fewer people ever saw. Americans built adequate helicopters that proved the concept globally. I learned that being right about technology matters less than being effective at deploying technology. Germany was right about helicopter potential. America was effective at helicopter production. Effectiveness defeats correctness in war. Hannah Reich survives the war, remains in Germany, continues aviation work post-war despite being banned from powered flight for several years by occupation authorities. She becomes an advocate for gliding and light aircraft. In a 1975 interview, she reflects on the R-4. "The American helicopter showed me that perfection is less important than practicality. We Germans always sought the perfect solution, the most efficient, the most elegant, the most advanced. Americans sought the practical solution, the one that works with available resources and can be built in quantity. During war, practical solutions win. I was frustrated to learn this, but it was true. The R-4 was not perfect, it was practical. That was enough." Kurt Schwenke survives, works in post-war aviation industry in West Germany. contributes to helicopter development programs that eventually lead to German participation in international helicopter projects. In a 1970 technical paper on helicopter maintenance, he writes, "The R4 taught me that maintainability is a design requirement, not an afterthought. German pre-war helicopter designs prioritize performance, assuming maintenance would be performed by specialists in controlled environments. American R4 design prioritized field maintenance, assuming operations in austere conditions by minimally trained personnel. The American assumption proved correct for military operations. Modern helicopter design incorporates maintainability as a primary requirement, a lesson learned partly from the R4. Heinrich Schinn survives, continues engineering work in post-war Germany, contributes to various aerospace projects. In a 1982 interview, he reflects on the R4 evaluation's broader implications. The R4 was a case study in how industrial capacity determines technological outcomes. Germany had superior helicopter engineers, Volk Flettner, others who solved rotary wing flight problems years before Sikorsky. But Germany lacked industrial capacity to exploit their discoveries. America had adequate engineers. Sikorsky was certainly capable, though perhaps not as brilliant as the German pioneers, but tremendous industrial capacity to transform concepts into production reality. The combination of adequate engineering and superior production defeated the combination of superior engineering and inadequate production. This pattern repeated across multiple technologies during the war. We learned painfully that genius without resources loses to competence with resources. The Sikorsky R4 continues serving with U.S. forces through the end of the war and into the post-war period. Production totals 131 aircraft operated by Army Air Forces, Navy, and Coast Guard. The R4 flies thousands of operational missions, saves hundreds of lives, proves helicopter utility conclusively. The R4's operational success justifies continued helicopter development, leading to improved models. The R5, R-6, and eventually the H-19, H-34, and other helicopters that become ubiquitous in Korean and Vietnam conflicts. The R-4 is retired from military service by 1950, replaced by improved designs, but its legacy is permanent. It was the world's first mass-produced helicopter. The aircraft that proved rotary wing aviation was practical for military operations. The machine that transformed helicopters from experimental curiosities to operational tools. Several R4s survive in museums today, restored beautifully, displayed prominently in aviation collections. They look fragile, primitive, almost toy-like compared to modern helicopters. Visitors often express surprise that these simple machines flew combat missions, saved lives, proved a revolutionary technology. But pilots who flew them, mechanics who maintained them, soldiers whose lives they saved, they understood. The R4 was not impressive by performance standards. It was revolutionary by operational standards. It worked. It could be built in quantity. It could be maintained in the field. It could be flown by adequately trained pilots. And most importantly, it existed when needed, where needed, in numbers sufficient to matter. German helicopters were more advanced technologically. The R4 was more advanced operationally. Operational advancement won. The broader lesson of the R4 evaluation extends beyond helicopters to fundamental questions about technology development during conflict. Germany's approach pursued technological superiority through advanced engineering, developed cutting-edge designs, produced small numbers of exceptional equipment, worked well early in the war when Germany was on the offensive, when technological surprise provided advantage, when quality could offset quantity. But by 1944, the war had changed. Attrition favored quantity. Industrial capacity determined outcomes. Advanced designs that existed in tiny numbers were operationally irrelevant. Adequate designs that existed in large numbers dominated battlefields. The R4 was adequate. It was not exceptional. But 131 adequate helicopters deployed globally had more impact than 35 exceptional helicopters deployed experimentally. This tension between quality and quantity, between technological excellence and industrial production, characterized Germany's entire war effort by 1944. German tanks were superior to Allied tanks, the Panther, the Tiger, technically better than the Sherman or T-34, but Germany produced 6,000 Panthers. America produced 50,000 Shermans. Russia produced 57,000 T-34s. Superior quality was overwhelmed by superior quantity. German jets were superior to Allied fighters. The Me-262 could outperform any piston-engine fighter. But Germany produced 1,400 Me-262s. America produced 15,000 P-51 Mustangs. Superior performance was irrelevant when outnumbered 10-1. German submarines were sophisticated, with advanced technology. but they were produced in insufficient numbers to control the Atlantic against Allied shipbuilding that replaced losses faster than submarines could sink ships. The pattern repeated everywhere. German technological excellence defeated by Allied industrial capacity. The R4 evaluation crystallized this reality in microcosm. Here was a technology Germany pioneered, where German engineers led the world in understanding and capability, where German designs were objectively superior. Yet America dominated operationally by transforming experimental technology into production reality. The lesson was clear but unacceptable. Innovation alone does not win wars. Production wins wars. Germany could innovate faster than any nation on earth, but innovation that cannot be produced in quantity is irrelevant. America might innovate slower, might accept adequate performance instead of optimal performance, might build designs that engineers considered primitive, but America could produce thousands of adequate designs while Germany produced dozens of optimal designs. Thousands beat dozens. Every time. The German test pilots who flew the R4 in September 1944 understood this immediately. They recognized that the primitive American helicopter represented something profound: American willingness to deploy emerging technology at scale, American industrial capacity to transform concepts into reality, American systematic approach to new capabilities. They understood that their reports, accurate and thorough, would change nothing. Germany in September 1944 could not suddenly develop American-style industrial production. The gap was too wide, the time too short, the resources too scarce. They wrote their reports anyway, documenting what they found because professional integrity required honesty regardless of consequences. Post-war analysis of helicopter development during World War II confirms the German test pilots' findings and expands on their implications. Historians studying comparative aviation development identify the helicopter program as exemplifying broader patterns in technological competition during the war. Technical papers published in the 1950s through 1980s use the R4 versus FL-282 comparison as a case study in design philosophy, manufacturing strategy, and operational deployment. The consensus conclusion across multiple studies: Germany won the engineering competition but lost the production competition, and wars are decided by production, not engineering. Modern helicopter development incorporates lessons from both German and American World War II programs. German contributions: rotor dynamics, understanding, control system sophistication. Advanced configuration concepts informed post-war helicopter design globally. American contributions: production engineering, maintainability emphasis. Operational training systems informed post-war helicopter deployment globally. The synthesis of German innovation and American industrialization created the modern helicopter industry. Neither approach alone was sufficient. Combined, they enabled the rotary wing revolution that transformed military and civilian aviation in the post-war era. The story of German pilots flying the captured R4 is ultimately a story about recognition and acceptance. Recognition that technological superiority does not guarantee victory. Recognition that industrial capacity determines strategic outcomes. Recognition that adequate equipment in large quantities defeats superior equipment in small quantities. And acceptance that Germany, despite pioneering helicopter technology, had lost the helicopter development race not through inferior engineering but through insufficient production. That recognition came too late to change outcomes. That acceptance was bitter but necessary. The test pilots who flew the R4 understood what many in German leadership could not accept. The war was lost not because German engineers failed, but because German industry could not match Allied production across any domain: aircraft, tanks, ships, or helicopters. The R4 was proof, simple and incontrovertible, that America had transformed experimental technology into operational capability while Germany's experimental technology remained experimental. That transformation, repeated across dozens of technologies, decided the war. The helicopter was just one more example. The R4 evaluation revealed that innovation alone doesn't win wars. Production, deployment, and operational integration determine outcomes. German engineers were brilliant. American industry was overwhelming. The combination of adequate engineering and superior production defeated superior engineering with limited production. If you want more stories about how industrial capacity shaped World War II's technological battles, subscribe now. We publish these primary source investigations every week, uncovering the lessons that shaped modern warfare. Thanks for watching.